Hi, so I did problem 16-95, which is as the car travels forward at 80 feet per second, the rear wheels have an angular velocity of 100 radians per second, and it asks to determine the speeds at A, B, and C. So here's kind of like the zoomed in part. That's A, B, C. I labeled this part as O. And I kind of had some trouble with this one. But I kind of figured it out after reading a lot of different things. So the first thing I did was I had to find the instantaneous center of rotation. So I don't know if you can see this graph. Or here, I'll actually draw it bigger. So to find the instantaneous center of rotation, there's gonna be a point on here where I think it's like the velocity is 0, if I'm correct. So there's gonna be some point around here that I called I C, which is and basically, it's there because based off of the problem, there's gonna be a velocity right here, which will be V, and some velocities, VC and VA. And I read that to find the instantaneous center, you connect these lines that's perpendicular to the velocity. So this one would kind of go like that. And it should lead up to this point. So to calculate that point, first we knew that the velocity at O is 80 feet per second, which is given up here. And we can also write this. So VO is 80. So we get that the radius, or the position is 0.8 on this little part right there. And after that, I calculated VA, which is this one right here. And that would be WR of A in respect to IC. And VA would equal 100 again. And here, R of AIC would be the (1.4) minus that 0.8, so you're looking for that part. J. Negative. So here we can write and the magnitude of this part is just 0.6. Which equals 60. And then next I did the velocity at C, which is kind of similar. It'd be 100, but this time R of B IC would be this 1.4 plus the 0.8, which is that radius, J. Which equals 2.2. And that's the final answer for the velocity at c. And then for part B, you have W wait, this is C. And this time, this position vector is gonna be, or the angular position, sorry, is gonna be this portion right here. I'll write it down. And that's gonna equal because of the little triangle you have. And then this is what we're looking for. And that turns out to be 1.612, and you just plug it back in. So 100 times the 1.612. And that's the last answer I'm looking for. And I think that's it. So basically I just use this as the reference point and found the radiuses from C to B to A, and those corresponded with the angular positions R. And once you found those values, then you would just plug it into the equation and you could calculate the velocity based off of this point right here. And there's the whole thing.